Hello, my name is Muntabir Hassan Chaudhary, and I am a PhD student in the Department of Computer Science at Old Dominion University. I'm going to talk about some of the key aspects of our poster titled MetaEnhance, Metadata Quality Improvement for Electronic Thesis and Dissertations. In this poster, we are trying to emphasize to adopt the AI-based method to improve the quality of the metadata rather than relying on some of the manual approach or semi-automatic approach that has been proposed in the previous research work. Metadata quality is very important for digital objects to be discovered through digital library domains. However, this metadata often exhibits incomplete, inconsistent, and incorrect values. So the existing framework, as I said already, that relied on semi-automatic approach or manual corrections such as crowdsourcing, which allow users to correct the metadata manually. However, these methods are slow and biased toward document discoverability. So we took the electronic thesis and dissertations. In short form, we are going to call it as a ETDs. So we took these ETDs as a case study where we found poor metadata quality, and this may harm the discoverability of digital library. And we come up with a solution with a framework that is called as MetaEnhance, which utilizes the state-of-the-art artificial intelligence methods to improve the quality of the metadata on a benchmark data set for evaluation tasks, which contains 500 entities. And our framework achieved a remarkable performance on the benchmark data set by automatically detecting, correcting, and canonicalizing the surface values of 7 key metadata fields, including title, author, university, year, degree, advisor, and department field. In our MetaEnhance framework, we can see that it is comprised of three main modules: error detection, correction, and canonicalization. First, we want to detect three types of errors: missing values, incorrect values, and misspellings. Then the correction module would correct, canonicalize, and utilize the automata to fill in missing values and overwrite any incorrect metadata by directly extracting the metadata from the ETDs. Automata is a tool that has been developed in a previous research study to directly extract the metadata from the electronic thesis and dissertations. We noticed that the heterogeneous nature of the metadata fields. So therefore, we cannot define a single system that can identify the errors and correct errors. Therefore, we come up with various methods by observing each metadata fields and propose some of the methods to detect and correct the errors. For the title, we found erroneous titles, such as DMA recitals. So we adopted title classifier by Rohatgi et al. To detect some errors. So this title classifier has achieved state-of-the-art performance to classify the title, and it achieved 96 to 99% F1 score. So any incorrect title that has been identified was overwritten with the automata result. For the author and advisor field, we adopted the FLAIR NLP, which is a name entity recognition model. It is a state-of-the-art model. So if the author or advisor name is classified as a type other than person, we considered it as incorrect and was overwritten with the automata result. For the university field, we found only acronyms. From the table 1, we can see that the acronym for university field is OSU, and the full name is Ohio State University. So we built a dictionary-based method to classify the acronym as an error. And then once it detects as an error, we try to canonicalize that acronyms. So canonicalization basically means that we have several different forms of the same entity. However, we would like to map them into one single entity and a full name and store that value in the full name. Basically, we want to store that value in the standard format. So if any acronym exists, in the university field, then the correction module would canonicalize and replace the acronyms with the full names. For the degree field, we also found the acronyms. As you can see from table 1, we have MS, M.S. which basically refers to the same entity, which is Master of Science. We also found the incorrect metadata in the degree field, such as history. History belongs to the department field. However, we would like to um, detect this incorrect metadata and acronyms, and therefore we built a dictionary-based method consisting of the degree full names and acronyms. So if an acronym exists, we canonicalize the degree field by the correction module and replaces the acronyms with their full names, as well as for the incorrect metadata fields, we replace those incorrect metadata with the corrected metadata by extracting the um, metadata directly from the ETDs using Automata tool. For the department field, we also found numerous misspellings, which is basically school of music, where in the school, the H is missing. So we used file spell checker, which is basically using the Level Science Distance algorithm, which basically provide us the permutation of insertion, deletion, or substitution to detect and correct errors. Also, we found some of the different forms of the same department names. As you can see from the table 1, we have MSc and MSCE, which belongs to the same entity, which is material science and engineering. So to disambiguate the surface name, the module used the sentence transformer and dictionary-based method. So the sentence transformer, what it does that it would give us the embedding of the surface name as well as the department full name. And then we would measure the cosine similarity to get the best matches of the acronyms. And we found that the cosine similarity is greater than 0.91 would give us the best matches for the department names. For the year field, we found inconsistent format across libraries such as month, date, year, or year, month, and date. So we used a Python built-in function called dateutil.parser.parse and dictionary-based method to detect errors. If an error exists, we override the value from the automata. To canonicalize, we use the regular expressions and dateutil.parser.parse to parse and store year, month, and date into 3 separate columns in order to not losing the information of the year field. So for our evaluation results, as we already talked about that, we compiled a benchmark data set which consists of 500 ETDs metadata, which is selected from the over 500,000 ETDs by crawling 114 US university libraries and ProQuest. We evaluated against this benchmark and reported precision, recall, and F1 scores. From our table 3, we can see that the error detection module achieved F1 score greater than 0.99 for the title, author, and department fields, and perfect recall and precision for university year and degree field. As you can see from table 2, the distribution of ETD errors in the 500 benchmark dataset. So in order to avoid the bias in the dataset, we collected the ETDs, but made sure that it has missing values, it has some canonical forms, it also has some misspellings, as well as the incorrect values. As you can see that, except the title field, we have missing values for the remaining fields, except the title and author field. We have lots of canonical forms of the advisor, year, degree, advisor, university, year, degree, and department field. For these misspellings, we only found 2 misspellings in the department field, and the incorrect incorrect metadata, we found 1 incorrect metadata in the title field, and for the degree field, we have 4 incorrect metadata. Then we try to apply the error correction module and canonicalize the surface values. However, this performance of this ECC relied on the output of the automata. So except title and author, the correction module successfully corrected all missing values. Also, the module successfully canonicalized the surface names. Also, the correction module canonicalized 7%, 6.4%, 0.2%, 16.2%, and 16.6% for the advisor, university, year, degree, and department fields, respectively. Table 3 shows that error correction module successfully corrected 4 incorrect values and 2 misspellings for the degree and department fields, respectively. From our error analysis, we found that one false positive and one false negative for the title field. For example, DMA recitals was misclassified as valid. We also found two false positives for the author field. For the advisor field, the error detection achieved F1 score equals to 0.95 with 37 false positive. The department classifier correctly detected two misspellings, but misclassified two surface values. For example, public health belongs to the department field, but it was classified as an incorrect department name. In conclusion, MetaEnhance demonstrated effectiveness in automatically improving ETD metadata quality when evaluated on 500 benchmark datasets, and it also achieved 95% to 99% F1 score in detecting errors and corrected 85% to 98% F1 score. The only limitation of this framework is that it utilizes the dictionary-based approaches for university degree and department field to detect errors, and which may misclassify if the surface values do not found in the dictionary. Thank you.